So I already talked about these equations so far. This one is linear since it just has an x. I would solve it like normal. Then I've got the quadratic equation. Because of my x squared here, I can factor if possible, or I could use the quadratic formula to solve that one. And then I have two systems of equations. Because there's two equations and two variables, I can solve them by the elimination method or the substitution method. If I really want to, I could solve it by graphing, but I would choose the other two ways first. And then I've got this proportion. Before I decide whether it's linear or quadratic, I'd want to cross multiply, and then I could decide. This one actually happens to be a linear equation. Okay, so let me show you how to solve each of these 5 types of equations. Okay, so for this linear equation, it's just 3x minus 11 equals 0. The first thing that I like to do is drop a line where my equal sign is, and then I'm going to do the opposite or the inverse operation to both sides so that my 11's cancel here, and I end up with 3x equals 11. And then I need to divide by 3 so that I have 1x, and I end up with x equals 11 thirds. Oops. If I want to divide it, I can, and I would end up with 3 2/3. And I'm done. You can always check it by plugging it back in for x and making sure that it does equal 0. Okay, so here is a system of equations, and this is the one that I suggested we solve using the elimination method. Since my x's and my y's and the equal sign, everything's lined up nicely. I notice in the top row, the top equation, I have a negative 3y, and the bottom equation I have a negative 1y. If the bottom equation was a positive 3, then my y's would cancel. So what I'm going to choose to do is take my bottom equation, and I'm going to multiply it by negative 3. And when I do that, I end up with negative 6y plus 3y equals negative 36. And rewriting the top equation, I had 7x minus 3y equals 37. Now I'm going to add these. Sometimes in elimination you subtract. I prefer to add. And I'm adding because I ended up with opposite signs for my y's, so they cancel. Negative 6y plus, or sorry, that should have been an x there. Negative 6x plus 7x is 1x. And that ends up being 1. So that kind of turned out nice for me. So my x value is 1. And since I had a system of equations, I need to find the y value. I know x now, so what I'm going to do is go up to one of my original equations up here. And instead of x, I can type in a 1. So what that's going to look like is 7 times 1 minus 3y equals 37. So 7 minus 3y equals 37. Now I need to subtract 7 because it's a positive 7. And when I do that, I end up with negative 3y equals 30. And to finish it up here, I'm going to divide by negative 3. And I end up with y equals negative 10. So I have two answers. I have the x value is 1 and the y value is negative 10. I just want to make sure that I'm right, especially if this is going to be put online. So I'm going to take this other equation up here, and I'm going to substitute 1 for x and negative 10 for y. So 2 times 1 minus negative 10. And I'm trying to decide if that really does equal 12. So I end up with 2 plus 10, and yes, that does equal 12, so I am right. Here's my two answers. X equals 1, and y equals negative 10. Okay, this one was a proportion, and to solve a proportion, I'm going to cross multiply here, and that's going to give me 7x. There's an equal sign in the middle. Tricky part about this right here is that I need to make sure that I distribute the 5 to both the x and the 1. So that's going to end up being 5 times x, which is 5x, plus 5 times 1, which is 5. And then it's just a regular old equation. So I, again, like to drop my line. I am going to subtract 5x from both sides since the right only has an x. And when I do that, I get 5 equals 2x. And now I'm going to divide by 2. And that's going to leave me with x equals 2.5. And I'm done. Now that one, it ended up being linear. If you look at what the equation was like after we cross multiplied, it was linear. There could be a there could be a proportion where maybe it's something like x over 5 equals 2 over x. And when I go to cross multiply, I get x squared. And so if I get x squared equals 10, technically that's a quadratic equation. I could take the square root of both sides to solve, and I'll get x equals plus or minus the square root of 10. So just so you know, sometimes when you see a proportion, it would end up being quadratic because you see this x squared.
Don't you have to plug x in for?
This one is a quadratic equation because of the x squared. I know it doesn't really look like an x squared, but that's what that caret symbol means right there. And so when I have a quadratic equation, I have two options. I could try to factor it, or I could use the quadratic formula. I think factoring is easier if it can be factored. I'm going to do it the long way here. So I'm going to set up my generic rectangle. My x squared first term goes in the first box, my last term goes in the last box, and then I have my little diamond problem on the side here. The middle term is 5x, so that's my sum. 6 times x squared is 6x squared, so that's my product. And so now I need to find two numbers so that when I add them I get 5x, and when I multiply I get 6x squared, and that happens to be 2x and 3x. So when I go to replace them over here, it doesn't really matter which box I put them in. And then factoring, my top row here, the greatest common factor is just x. And then it's going to be x times x is x squared, and then x times 3 is 3x, and then x times 3, oops, I messed up there, didn't I? Sorry about that. This should have been a 2, not a 3. So that's going to change this one. So that's going to be x times 2 is 2x, and then 2 times 3 is 6. So factoring gives me x plus 3 times x plus 2. It was an equation, so it equals 0. And now using the zero product property, I'm going to have x plus 3 equals 0, which leaves me with x equals negative 3. And then I have x plus 2 equals 0, which leaves me with x equals negative 2. And there's my two answers for my quadratic equation. Okay, so this is a system of equations, again, because there's two equations and two variables. Since y is by itself over here, I am going to choose to solve this one by the substitution method. And so all of this here, all of this is equal to y, so I'm going to put all of that in place of y in my equation. And that's going to give me then 2x plus 12 minus 3x equals 6. What that does for me, it gives me a linear equation. I have one variable, and I can just solve it. Since the 2x and the minus 3x are on the same side, I can just combine them together. I'm just combining like terms. So that's giving me negative 1x. I still have plus 12, and it still equals 6. And now I'm going to subtract 12 from both sides. That's going to give me negative 1x equals negative 6. And I need to divide by negative 1 so that I have a positive x, and x equals positive 6. So I have my x value, and since it's a system of equations, I need to plug that back in to find my y value. So I'm going to do that over here. I am going to choose to use the first equation, especially since y is already by itself. So it's just going to be 12 minus 3 times 6. And y equals 12 minus 18, so y equals negative 6. So I've got two variables. I am going to use the bottom equation here to check my answer. So if I am right, then 2 times 6 plus negative 6 will equal 6. And 12 plus negative 6 does, in fact, equal 6, so I know that I am right. Okay, back to the original screen. So, you know, towards the end of the year, and now that you guys are done algebra, your teachers are going to expect that no matter what kind of equation you get, you're going to be able to solve it. So don't stress out. Just take a second, think about what you're given and what it looks like, and you can do it.